Hi there, my name is Harrison and I'm a tutor with Chegg Tutors. Today I'm going to talk to you about least squares. The method of least squares is the most common way to determine a line of best fit for a data set. Let's say you have some data and you want to perform a regression analysis on it. In other words, you want to find a line of best fit for these data. We can use the method of least squares to do this. This method takes into account all of the squared residuals of the data and minimizes them. A residual is the offset of a data point from the function that's modeling it. If we use a linear function to model these data, the function is going to give us a predicted value, y hat. This is a predicted value for the dependent variable, so we call it y hat to indicate that these are not the actual values. The actual values are our points that are scattered around the line. The independent variable, x, is assumed to be the explicitly measured or tested variable, so we don't care about the residuals in x. Because we only care about the offset of y, not the offset of x, we only care about this vertical offset from the line. So like that. Here, let me do a few of these so it becomes clear. The residuals aren't perpendicular like you might think. Because we don't care about x, they aren't like the lines I'm doing in green. It's always just the vertical. This might seem like a subtle point, and it is. But it's also important because it makes the math quite a bit easier. So the residual is y minus y hat, where y is the actual value and y hat is our predicted value. So for this point, our y looks like it's about 42 minus our y hat is probably 57. So this residual is probably about negative 15. And this one looks like, oh, it looks like 40 minus 46, so about negative 6. Let's just go through and calculate all the residuals for this problem. Here we go. I time skipped there. I went through and I calculated all of the residuals in Excel for all 38 of the points on this scatter plot that I made. And so now all we have to do is minimize the residuals, right? So to do that, we should probably just add them up. But when we add them up, when we add all 38 of these residuals up, we get 0. So why is that? All of these residuals add up to 0 because there are both positive and negative values. As we saw here, this is a positive residual, this is a negative residual. This happens because the line of best fit goes straight through the middle. The residuals on the bottom add up to the residuals on the top, and they cancel out. The fix for this is to square the residuals. I did that really quick in Excel too, and these are our squared residuals here. The reason that works is because when you square a negative, you get a positive. So this makes all of the squared residuals positive. The line of best fit is the line for which the sum of these squared residuals is minimized. That's where the name comes from. The best fit line is the line of least squares. It's important to note the drastic effect that outliers or unusual points can have on the data. So here's some normal, here's just a normal scatter plot with a linear regression that I did in Excel. And let's see what happens when we add an outlier, say up here. So this red line on top is the linear regression of the data with an outlier. The blue line on the bottom was our regression from earlier. And this really changes the regression line. So keep an eye out for outliers. For the most part, I've been talking about the linear least squares method. This is definitely the most common, and it's also called the method of ordinary least squares, or OLS. But there are least squares for nonlinear data. These are complicated, and they're not used particularly often. Usually, people try to regularize the data by some transformation to make it into a straight line, and thereby make use of the linear least squares method. I hope this has been a good overview of the method of least squares. Thanks for watching.